Yes, today we are going to see a very simple example or very simple type. I will say this is the type one of a first order partial differential equation. Okay, so the type is here f of pq is equal to 0. So at the beginning we see the general form of the partial differential equation is f of x, y, z, comma p, comma q is equal to 0. This is the and or general form will say function of x, y, z and pq, that is a relation between the five things, three variables x, y, z and two partial derivatives dou z by dou x and dou z by dou y, that is p and q. So the relation between these five things is the partial differential equation, first order partial differential equation. So if in the differential equation, if in the differential equation, suppose only p and q appeared, that is the form 1. Okay, if in the differential equation only pq appears, then that form is known as f of pq. The solution of that form is taken by a very simple way. Uh, Always the solution of f of pq form is z equal to ax plus by plus c, where where one of the constant we have to eliminate by this equation, because we know the first order PDE will have only two arbitrary constants in the solution. So here a, b, c, these are the three constants. So we have to eliminate one of the constant, and to eliminate this constant we have this relation. So in this case, if you see the example, we have to solve p minus q is equal to 1. So as x, y, z are not present in the equation, that means only p and q are present. So the equation is in the form of f of pq equal to 0. So directly we can say the solution is this one, where replace p by a, q by b, and we get the equation a minus b is equal to 1. So this gives us a is equal to b plus 1. So we replace here in the solution, so we get z equal to b plus 1x plus by plus c, and that is a general solution, or that is a complete solution for the given PDE. So this is one of the simple example or the simple type. Remember, yes, even though this example is not coming in the exam, but a few examples of reducible can come where you should know the solution of this form. So don't think this is not important. These examples also can come in the exam. We'll see tomorrow in the Zoom session. The other examples or the other way of doing these examples also. Okay, so that's for today. We'll stop here. Okay, good evening all. So we are going to start here the third form, known as a PQZ form. Okay, so already we discussed in the beginning the general form of the differential equation is like f of x, y, z, pq equal to 0. Out of that, suppose only pqz are present, means if the differential equation is of only three variables p, q and z. Okay, this is in terms of only three things p, q and z. Then the method to solve the differential equation is this one. Always we take substitution in that u is equal to x plus a y. Now you will observe z is a function of u we have to take, and that u is a function of x and y. So there is a chain rule for the value of a p. The value of p is a dou z by dou x, and that can be taken as z to u. So it is a single variable. I will say dz by du into dou u by dou x. So that's a chain rule. So we have to go from z to x. This is like a tree diagram. So z is a function of u first, and then u is a function of x. So dou z by dou x become dz by du into dou u by dou x. So dou u by dou x we can calculate here. Dou u by dou x is 1. The value of dou u by dou x is 1. So the value of p, I will write it here. The value of p becomes dz by du. Similarly, if we observe the q there, q is a dou z by dou y, and that dou z by dou y become dz to u, this is z to u and u to y. So dz by du into dou u by dou y, dz by du into dou u by dou y. So dou u by dou y from this expression, you will observe the dou u by dou y, derivative of u partially with y is a. So this is a dz by du. So the value of q is a dz by du. Whatever the derivation we done it here for p and q, this is not necessary to do it in every example. Just you have to by heart the three things. First, you have to observe whether the form is f of pqz. It is only in pqz. So if our form is in pqz, uh, the first thing that you start the substitution. Let u is equal to x plus ay, and next you should remember when the value of p becomes dz by du, the value of q becomes a dz by du. And what happens that partial differential equation is converted in ordinary differential equation, and we can solve by our ordinary differential equation method. Now let me come to the example. So one example we'll see right now. The other examples we'll see in tomorrow's Zoom session. So the example that we are here is solve P into 1 plus Q is equal to QZ, and you will observe the differential equation contains only three things, PQ and Z. So this is the form f of PQZ, f of PQZ. That is the form that first you have to observe. So once you identify, we'll start. Let U is a x plus ay. So directly you can say therefore P is a dz by du and the value of Q is a dz by du. So when you replace in the given equation the value of P as a dz by du is the value of P, then the value of Q is a dz by du. Again Q is there, a dz by du. So simplify that. Once you simplify, see one dz by du gets cancelled directly outer, and then dz by du is equal to this dz by du is equal to az minus 1. This one is taken on the RHS. So this is the simplification. Once you get that simplification, it's written in variable separable form. The terms of z collected on LHS and terms of u on the RHS. So this is in VS form. And once you get VS form, just integration gives us the answer. So you can observe the derivative of az minus 1 is present in the numerator as a dz. So this is f dash x upon fx form. So log of az minus 1 is the integration of LHS, integration of du is a u, and b is this is the p is a constant of integration. So you can write b or c, nothing. So don't forget to resubstitute. Don't forget to resubstitute the value of u. The value of u is replaced here as x plus ay. So final answer is here log of az minus 1 is equal to x plus ay plus b, and you will observe there are two arbitrary constants in the final solution. So this is the solution of a first order PDE. So that about the solution of a first example. We'll see the other examples in tomorrow's Zoom class. Thank you. Okay, bye bye. Okay, good evening. So we are going to see the next type here of the partial differential equation. So the next type that we have is variable separable form, which is f1 of xp equal to f2 of yq. Whenever the terms of xp, first of all, the equation should contain only the four things x, y, p, and q. Okay, if the equation contains the four terms x, y, and yq, and the terms of xp and the terms of yq we can separate on two sides of the equation, then it is known as a variable separable form. Okay. Right now, whenever it comes f1 of xp equal to f2 of yq, assume is equal to some constant. Here we assume that is equal to some constant, and the constant is a is taken here. Okay, let me say a is that constant. Then from this we can find out the value of p in terms of x and a, and the value of q in terms of y and a. Then there is well-known relation known as a dz. Dz is equal to p dx plus q dy. That will use it. Replace the value of p and q, whatever we calculated, and integrate it, you will get the answer. Now, if someone have the doubt how this relation is true, I will show you here. If you have z as a function of z is a function of xy. Okay, so take a total derivative. So derivative of z is a dz. Now z is a function of xy. Z is a function of xy. So first it will come f dash means dou f by dou x dx plus dou f by dou y dy. What is f? F is a z. F is the function z. So this dou f by dou x means dou z by dou x. Dou z by dou x is a p, and dou z by dou y, that is a q dy. So what are the things you should remember? First of all, the equation should contain the four unknown xp and yq. Xp and yq should be separated on the two side of equation. Assume is equal to one constant a, replace that in dz is equal to p dx plus q dy, and integrate it. We get the answer. So that about the form 3. Okay, so let I show you the examples here. So there are total 25 examples up to you can see here up to 25 there are the examples. This is the first example. So right now we completed the first, second, third, fourth, fifth, sixth, seventh, eighth. This is ninth example is in that form. You can observe pq and xy are there. So this is the form of xp equal to yq. There are some others also, some other examples may be there. So that also you have to find it and you can complete it. So let me go to the example. We'll do the example number 9. Okay, so that about a theory. Okay, so let me see the example. So the example is that example number 9 that you are observing, that is a p square plus q square equal to x plus y. So you can observe p square minus x. This x is taken in the LHS and that q square is taken in the RHS. So p square minus x equal to y square minus q. So variables are separated on the two sides. So it is in the form of f of xp equal to f of yq. We assume is equal to the constant a. Let we assume it. So from first and last thing, we get the value of p square as a plus x. The value of q square is y minus a. So value of p is the root of a plus x. Value of q is the root of y minus a. Now this is the standard equation. You have to remember by heart it. So whenever you get the values of p and q in terms of x and y, we always substitute these values in dz is equal to p dx plus q dy. Just to replace that values and integrating, the integration is done, we got the answer. So this is one of the simple method. Identification is the most important thing. You should able to identify example. Okay, so that about the example. Let me stop here. Okay, so we are going to see here uh, fourth method of a nonlinear differential equation. The fourth method of nonlinear differential equation is a Clairaut's form. So this is the first, second, third, and now right now we are in the fourth. So Clairaut's form, z is equal to px plus qy plus f of pq form. So whenever we observe the differential equation is in the type px plus qy plus f of pq. If that is the differential equation, just replace p by a and q by b, we get the answer. So this is one step answer. So definitely these questions, this is not important type. None of the question was asked in the previous papers also. So it is one of the simplest differential equation. And the solution is obtained by just replacing p by a and q by b if it is in the Clairaut's form. Let me come to the example. So the example, let me see, is there any example of the Clairaut's form? Yes, I hope you can guess that. The example is example number 10. Okay, so example 10 is in the Clairaut's form. You can see z equal to px plus qy plus f of pq. This is the function of pq. It can be anything. So its answer, the answer for this is one step. Therefore, the solution is z equal to ax plus by, just to replace p by a, q by b plus root of 1 plus a square plus b square. So that is the answer. So 1 plus this is a square plus b square. So one step answer, that is answer of the example 10. So remember, these questions are not important, will not come in the exam, but that is one of the type. Okay, I hope it is clear, the form. Now I will tell you about these methods. So whatever the methods that we seen, the method Lagrange's method, f of pq, f of pqz, x equal to yq, and the Clairaut's form. So together these five methods, mainly these four methods. Clairaut's generally it not come in the exam, so that have the weightage of 5 marks in the final exam. Now, next method that we are going to see in the tomorrow's recorded session, which is a Chapit's, that is alone itself, it is of 5 marks. So this is of 5 marks weightage. Okay, so do the practice of the examples. Near about I will tell you near about many examples you can do it from this solve from this exercise here. There are 25 examples. If you Ignore 3 4 examples, 2 3 examples. Majority of the examples you can complete it. Try to identify the examples and solve it. Okay, so that about the Claret's form. Good evening. So today we are going to see reducible form. Okay, so yes, this name is not in the handout. Reducible form. Reducible form. Now, if you see in the previous session, the forms we are completed are like f of pq. Lagrange's is a different. Okay, so Lagrange's will not come here. So the other forms which are of nonlinear are f of pq. So only p and q contains. Then pqz form. So in which only pqz present. And third form we see in xp equal to yq. So terms of xp and yq are separated on each side of the equation. And then we see in the Claret's form. Okay, so mainly that first three are important: PQ form, PQZ form, and the last one is XP equal to YQ form. Now, this is the next part that we have known as a reducible form. So, reducible form. Now, how to identify? How to identify the example is of reducible. So, whenever the terms of x are connected with p only, and terms of y are connected with q only. Okay, that means x should not connect with y. Okay, so this should not happen. So x should not connect with q. So x should not connect with q. X should not connect with q, and y should not connect with p. So only xp should be together and yq should be together. Then we can say it is a reducible form. Okay. Now, if you see the example 16 that were taken here from the handout only, the question is a solve x square p square plus y square q square equal to z square. The thing is here that two terms are there which are separated by addition. In the first term, x and p are connected. In the second term, y and q are connected. So that indicates we can do some substitution and it will convert in the one of the first three form. So right now, what I done, just we replace the value of p as a dou z by dou x. Okay, the value of q as a dou z by dou y, and equation written as it is. So x square dou z by dou x bracket square, because p is a dou z by dou x, q is a dou z by dou y, and you got the first equation. Now, in next step, what I done, this z is also taken in the LHS, and this square is written outside. So x by z, this is x by z bracket square plus y by z into dou z by dou y bracket square is equal to 1. So this is the very important thing, and that you should click that I can convert in this form. Now, if someone, suppose if someone is not taken this Z on LHS, that is also okay. You are going to get some other form. We'll discuss about this once we finish this example. Right now, I taken that Z on the LHS, and this equation happens here. And this equation, what I am going to do it is dou Z by Z, dou Z by Z, we are replacing by dou capital Z. Here is substitution. Dou Z by Z is a dou capital Z. So the notation is going to change here. So instead of dou Z, that Z is a small, dou Z by small z is equal to dou capital Z. Similarly, the other, this dou x upon x is equal to dou capital X I am taking. Okay, so dou x upon capital X, this one. Similarly, this dou z by z is already dou capital Z, but this dou y upon y is a dou capital Y. So that about third substitution. So because of that, the equation is converted into dou capital Z by dou capital X bracket square plus dou capital Z plus dou capital Y bracket square is equal to 1. And that is the reducible form. We'll see that. So by this equation, whatever we take in a substitution, that we from that we can get these values for resubstitution at the end. So at the end, we have to resubstitute the values of capital X, Y, Z, and that we get by integrating. If we integrate this equation, dou z upon small z is a log z. Integration of dou z upon small z is log z. Integration of dou capital Z is capital Z. Similarly, the others one. Okay, so that about resubstitution at the end. But from whatever the equation we written here, this equation can be converted in notations. Now we are using that small p and small q for standard notation. Small p indicates dou z by dou x with a small letters x y z we can say. But let me change a small thing here. Let me say it is a p square plus q square, where p and q we use a capital only, which indicates that capital P and capital Q are a different that is first order partial derivatives only, but with a different notations. So we got p square plus q square equal to 1, which is of the form f of pq, means only pq present. So solution will be z is equal to ax plus by plus c. The important thing you should note down here is I'm not written small xyz. These are capital xyz, because this partial differential equation is in terms of a capital xyz. Okay, that are capital X, Y, and Z. So because of that, the solution I written is a capital Z equal to A capital X plus B capital Y plus C. And now the same thing, from this equation we get relation between AB, A square plus B square is equal to 1. So value of B is a plus or minus root of 1 minus A square, we calculated, and replace, we got the solution in terms of two variable, that is two constant A and C. But don't forget to resubstitute the values of capital X, Y, Z. So this is the resubstitution and we got the answer. So that about the reducible form. Yes, at the beginning already I told this example also can be done in another way also. For example, I will clear these things. Okay, I will come to the next part. The same example can be done by converting in other form. So that form is, suppose by chance someone is not interested to take this z square in the LHS. So what you will get, x dou z by dou x bracket square plus y dou z by dou y bracket square is equal to z square. So this z square we are not going to take in the LHS. So this way also you can do it. So one example can be done in multiple way, but definitely this example is only of reducible. So here only two substitutions we are going to do it. That is a dou x by x is a dou capital X, and dou y upon small y is a dou capital Y. And because of that, this example will become this is a dou z is a small as it is upon dou capital X bracket square, dou z that small z but capital Y bracket square equal to z square. So we get here is a p square plus q square equal to z square form. So the equation is a reduced in the I will say the type 2, where pqz form. Now we know how to solve this pqz form. So for the pqz form, we always use a substitution. Let u is equal to, now I will use u is equal to x plus ay, but in this case we should not use a small x and small y, because these are the differential equation capital X, capital Y, and small z. So u is equal to capital X plus a capital Y. So that will be our substitution. Once we use the substitution, we get like dz by du bracket square, that is the value of a p, plus a square dz by du bracket square is equal to z square. Okay, so I will get dz by du bracket square is equal to z square upon 1 plus a square. So I will say dz by root z is equal to 1 by 1 plus a square, sorry, root of 1 plus a square du. And now integrating 2 root z, 2 root z is equal to u upon root of 1 plus a square plus c a solution. But at the end we have to resubstitute the values, 2 as it is, root z as it is. The value of u is capital X plus a capital Y, capital X plus a capital Y divided by root of 1 plus a square plus c, and at the end we are substituting capital X by log x, capital Y by log of y upon root of 1 plus a square plus c, and that's the final answer, 2 root z. So this is the final answer. So what is the thing that we get here? Because of this substitution we get capital X as a log of small x and capital Y as a log of small y, that we resubstituted at the end and we got the answer. So this is the another method of doing the same example. So you can do it by any of the way, both are the correct. Okay, so that's about the reducible form. The identification is most important thing. Okay. Okay, we'll start a second example. Second example of reducible form. So the example is taken from the textbook only. If you see the example that we have, the question is solve z square in bracket p square x square plus q square equal to 1. So the main important thing that we should observe that it contains PQZ that and X also. If only PQZ are there, we can solve it by the form 3. But right now this X is extra part which indicate you cannot solve it by our PQZ form. So, but the best part is there that P and X are connected together. That means they are appeared in a single term. So when the terms of X and P appeared in the single term, the terms of Y and Q, if are there, they are appeared in the single term, that is the reducible. So right now, only this term, if you convert into the capital P, we can solve it. We can solve it by a reducible form. Okay, so there are two ways again of doing the same example. One of the way is given as a solution in the textbook. You can go through it your own. I will show it by the other way. You can do it like this. If I want to do it like substitution with both for x and z, so I can do like this. I can rearrange the equation. This p square z square x square z square x square z square x square p square plus z square q square is equal to 1. So just I taken that z square inside the bracket. Now uh, this term I can write like this: z x dou z by dou x bracket square plus z dou z by dou y bracket square is equal to 1. Now, what should be a substitution which gives us in capital P and capital Q form? So here I can use this z into dou z is equal to dou capital Z. Let z dou z is equal to dou capital Z. But this dou x upon x, so dou x upon x is a dou capital X, and same thing. Okay, there is no substitution for dou y, because if you observe, dou y appeared in the single way. Or if you want to substitute, you can put dou y is equal to dou capital Y only. Means y small y equal to capital Y, that way. Otherwise, there is no need of substitution. Okay, those who are interested, yes, they can write like this: dou of small y is equal to dou of capital Y. So that are about our substitution. Now, by the substitution, dou z is equal to dou capital Z. Okay, the equation becomes this is a dou capital Z by dou capital X bracket square plus dou capital Z by dou capital Y bracket square is equal to 1. So again, it is converted in p square plus q square equal to 1. So we are converted in pq form. So the solution will be z equal to that capital Z is equal to a capital X plus b capital Y plus c. Here resubstitution will be there for where the value of I will take as a capital X plus root of plus or minus root of 1 minus a square y plus c. Now resubstitution of the value, you can observe capital Z, we can get it from this equation. Z dou Z is a dou capital Z. So capital Z is Z square by 2. So small z square by 2. So this is the value of capital Z. Capital Z is small z square by 2 is equal to a capital X. Capital X we get as a log x, a log x plus or minus root of 1 minus a square. What is capital Y? Capital Y equal to small y. Okay, so sorry, y plus c, and that is the answer. This is the final answer. So this is one of the way of doing this example. Second, the other way, what we are given in the textbook, let we see it. So in the textbook, they are taken like just replace the values of p and q. Z square is not taken inside, that is kept outside as it is, and whatever the remaining parts are there, like dou z by dou capital X is taken as a capital P. Okay, so this is a z square in bracket capital P square plus q square equal to 1. So it is converted in PQZ form, and it is solved by PQZ form, and you got the answer. So this is the other way. So choice is yours. You can do it by any of the way. Answer both are considered as a correct. One more important thing I want to tell you. Last 3 years, not a single example was asked in your final exam on reducible form. Okay, but that is a part of syllabus, and you should able to identify identification is not difficult. There are two more examples in our list of the 25 example. You can do it your own, and you one example is already sent as a solution on the WhatsApp, but one more example is there. You find it, solve it by the reducible method. Okay, till then, bye. So we'll see next method in the next session. Okay, bye.